Welcome back. Today's topic is electric fields and capacitance. In the last video lectures, we have discussed about Laplace equations, Poisson's equation, and we have seen how to employ these two equations for determining the potentials in the electrostatic fields. In this video lecture, we will discuss about the concept of capacitance and the electric field associated with it. I hope that by the end of this video lecture, you will be able to explain what actually the capacitance is and what is its significance in our electrical engineering. Before we start, let's have a quick introduction about the capacitances, which you might have already studied in your intermediate level. You might have seen that capacitor is just an electric device which is composed of two conductors separated by a dielectric medium and is capable of storing equal and opposite charges independent of whether other conductors in the system are charged or not. So it is just like two conductors storing equal and opposite charges. These two conducting, this is conductor 1 and this is conductor 2, and these are separated by a dielectric medium. And this particular combination is called as capacitor. So if the charge is stored here are plus q and minus q, and let us suppose, since these two are of opposite charges, let the potential between them is V. So the capacitance of this capacitor is normally defined by C is equal to charge, because equal and opposite charges, so charge by the potential difference between the two conductors. This is the basic formula. And normally the capacitance is measured in farads, represented by F. And the capacitance depends majorly upon the medium which you are using. As you have seen that this is the medium. If you vary the medium, then automatically the capacitance which is offered by this medium, it will vary. Normally, as already mentioned, the capacitance is measured in farads. A capacitor of 1 farad is astoundingly very large. So normally you find, practically, you find capacitances of 1 nanofarad or 1 into 10 to the power of minus 12 farad, which is 1 picofarad. Max you can find 1 microfarad and hundreds of microfarad like that. But you don't find 1 farad capacitor because it is of very large capacitor. And one more thing, when you're choosing a capacitor, it's not only the capacitance value, you are also supposed to choose how much voltage it can withstand. And what is the leakage current? So selection of capacitors, whenever you are choosing for a particular application, you need to have more concern about the capacitance and also how much voltage which it can withstand and the leakage current which it allows. Now, as already shown in the previous slide, the capacitors may not be always with the, just like these parallel plates. These two just look like parallel plates, right? So they may not be always like this. Sometimes you will be filling different types of configurations, just like one is parallel plate capacitor, spherical capacitors, right? This is the medium between them. This is a spherical capacitor, and sometimes you can find coaxial capacitors, or what we call them as right. This is a cylindrical capacitor, right? In electrical engineering, if you carefully see, even the transmission lines also, a transmission line, you know that you take a cable, what you find, a cable is just like it is a transmission line, right? Or over a transmission line, you can see that this is a transmission line. And you can see that there is another transmission line. A 3-phase transmission line will be like this, isn't it? So these are, literally speaking, these three are conductors which are carrying some charges, right? So this is conductor 1, conductor 2 and conductor 3, or what we call them as R by B, right? So these are conductors which are carrying charges, and most of the times they will be carrying equal charges in transmission systems. So automatically there will be a potential difference between these two, right? So when they are carrying charges and when there is a potential difference between them, then automatically what happens? There exists a capacitance between the lines. So always in electrical engineering, we do find conductors very close to each other, particularly in the transmission systems, right? And these, they do exhibit these capacitances between them. And also, if you take a single conductor also, and you're placing it far above the ground, and the ground is also just like a zero potential one. So which means that there is a potential existing between them. And this is a charge which is flowing. So automatically there is a capacitance with respect to ground also. So which means capacitances are lying everywhere. They are between the conductor and the ground. So we need to know what actually the capacitance is and how it is being calculated. That we will see in this lecture today. Okay. I hope now that you have understood what actually is a capacitance. And one more thing which I would like to say is capacitance with respect to electrical field. Yes, this term is actually missing today, right? See, whenever you are trying to develop some charges, I'll take a parallel plate capacitor. So automatically, which means that there is an electric field, right? A potential existing means automatically there is an electric field, right? So whenever there is an electric field, automatically you can expect that there can be a capacitance. If it is a dielectric material subjected to electric fields, then automatically it means that on either side of the dielectric field, there are some charges which are resulting in their electric field, and this will necessarily develop a capacitance. So in electrical engineering, we often find electric fields, so automatically we do experience capacitances. And in this video lecture, in the next video lecture, we will see the basic configurations of capacitors. Okay. Thank you. So the question is, what is the effect of increasing voltage on capacitance which is offered by any capacitor? That we have seen already. The voltage increases, automatically what happens? C is equal to Q by V, right? If the voltage goes on increasing, then automatically the capacitance may decrease. That in detail you are supposed to show me how, by giving some reasons, practical reasons. Try it at your home. Thank you.